So today's lesson is lesson 13, and we're moving from ratio tables to equations, and we're going to use the value of that ratio when we're making those equations. So remember, equation is anything where we have a left side and a right side, and there's an equal sign in between. So this would be an equation, 3 plus 2 equals 5. This would be an equation, 4 times 1 equals 4. So that's what we're going to be working on, connecting a ratio table to equations. Our I can statement is I can use the value of the ratio to problem solve by writing and solving equations. So we know what an equation is. Just a reminder, what is the value of a ratio? Well, it is that simplified fraction. So we're taking a ratio and we're writing it as a fraction, and then we're simplifying it. So remember, if this was my ratio 3 to 6, I would rewrite it as a fraction, 3 to 6, and then I would simplify. So what can I divide the top and the bottom by? Well, I can divide the numerator and denominator by 3, and I'll reduce it to 1/2. Alright, so let's continue. Ian is mixing a special shade of orange paint. He mixed 1 gallon of red paint with 3 gallons of yellow paint. Based on this ratio, which of the following statements are true? So before we start, let's look at our possible ratios. Well, one I have is 1 to 3, and that is my red to yellow. So that's going to be what I'm going to start at, and then let's look at our problems we have. 3/4 of a 4-gallon mix would be yellow paint. So what is that saying? Well, I'm mixing it all together, so it's going to be 4 to 3. Here is my yellow. Here is my total. So let's see if that's correct. 3/4 of a 4-gallon mix would be yellow paint. Well, what that would mean is I'm taking 3/4 and I'm multiplying it by 4. And let's check. 3/4 times 4, well, that's going to be 4 over 1. And I multiply straight across, so I will get 12 over 4 times 1, which is 4. And what does that reduce to? Well, I can divide the top and the bottom by 4. That's going to reduce till 3. Let's look at our picture right here. Here would be 4 gallons of paint. 1 gallon, 2 gallons, 3 gallons, 4. And 3/4 should be 3 of what color? Yellow. So 1, 2, 3. So that is correct. That is true. Let's check this next one. Every 1 gallon of yellow paint requires 1/3 of a gallon of red paint. Well, let's look at this one. Let's look up here. If I only have 1 part yellow, am I going to have a whole part red? No, I'm only going to have 1/3 of my red. Why is that? Well, let's look at it this way. If I have 1/3 of my red and 1 yellow, what happens when I have 2 yellows? Well, I need to add another 1/3 of red. So now I'm at 2/3 yellow, or 2/3 red and 2 yellows. If I add 1 more yellow, then I need to add 1/3. And look at that. I have 3 parts red, 3 giant parts yellow. That's my original ratio I started with. So that part is true because they are equivalent. Let's look at this next one. Every 1 gallon of red paint requires 3 gallons of yellow. Well, that's my original equation that I started with. Right here, 1 gallon of red, 3 gallons of yellow. 1 gallon of red, 1, 2, 3 yellows. So that part is also what? Solve it on Socrative, then continue. There is 1 gallon of red paint in a 4-gallon mix of orange paint. So let's check. If I have 1 gallon of red, that means I have how many yellows? Well, I'm going to have 1 yellow, 2 yellows, 3 yellows. What does this all make? Well, it told me right up here that it's making orange. So this is going to be 4 gallons. And how many reds do I have? Well, I have 1. So this is also going to be a true statement. Let's look at our last one. There are 2 gallons of yellow paint and an 8-gallon mix of orange paint. Well, what have I done here? Well, I started with my ratio 3 to 4 right here. That's my yellow to total. But now I'm doubling it. So this 4 has now become an 8. How did I make that 4 become an 8? Well, I multiplied by 2. So what do I need to do to this 3? I do the same thing. I multiply by 2. So let's check. It should be 6. Is that correct? No, this statement is false. If I wanted to rewrite it so it's true, what I'd have to do is this. If I wanted a true statement, I'd have to substitute this yellow, and I would change it for red. Why is that? Well, my ratio of red to my total is 1 to 4, and I'm ending up with 8 multiplied by 2, so I'd multiply this by 2. And I would get, 1 times 2 is just that 2. So there would be my correct answer if I had red. But since it was asking for yellow, my answer was incorrect. It was false. Okay, so we're going to use the same problem, but now we're going to do something a little bit different. So based on the information of red and yellow paint given in the previous problem, complete the table below. Red paint, I don't know. Yellow paint, I have 3. And my relationship is 3 equals 1 times 3. So how much red paint do I have? Well, if I look right here, I see I have 1 red for 1, 2, 3 yellows. So my answer is just going to be 1. Let's look at this next one, though. Here it's saying I have 2 red paints. So let's look. What would that look like? Well, it would be 1, 2 red paints. How much yellow do I have? Well, I have 1, 2, 3, 4, 5, 6. So my answer is going to be 6. What is this relationship? Well, let's look. What that means is, how am I getting this 6? Well, I'm taking this 2 right here, and what am I multiplying by? How do I end up with this 6? Well, it's easy. I'm multiplying by 3. So my relationship is yellow paint equals my red paint times 3. So let's look at this next one. It says I have 9 yellows. They're already telling my relationship. So let's look what 9 yellows looks like. It's going to look like that. 1, 2, 3, 4, 5, 6, 7, 8, 9. How much red do you see? Well, I see 1, 2, 3 reds. So that's how much red paint I have. And we see the relationship is the same. Yellow equals red times 3 is its relationship. So what's my next one? Well, here I see I now have 12 yellows. But they're not giving me the relationship this time. So let's fill out how much red do I have? I have 1, 2, 3, 4. So my red is going to be 4. Now let's look at the relationship. How did I get from this number to here? Well, I see that it is red times 3. I see that right up here. But I know what red is. They're telling me red is 4. So it's 4 times 3 equals what? Well, 4 times 3 equals 12. And if I check in my yellow column, that's what I should have for my answer. So I know I'm on the right track. So now let's see if we can fill out this bottom one. It's telling me I have 5 reds, so let's add another one. 1, 2, 3, 4, 5. How many yellows do I have? Well, I see it's 1, 2, 3, 4, 5 rows, and there's 3 in each column, so that's 5 times 3. So I'm going to have 15. Now let's look at the relationship. How did I get from 5 to 15? Well, that is 5 times 3. And what is my answer? Well, it's that 15 again. And I can check, because I have this pattern up here. It's red times what? Times 3 equals yellow. And my yellow says it should be 15. All right, let's continue. What information is given in this table? Well, we already discussed on the previous page. This table gives me the number of gallons of red paint and the number of gallons of yellow paint. So this 1 doesn't just mean 1 whatever. This is my red paint, and you see My red paint is related because it's all increasing by 1. Each time I'm increasing by 1. My yellow, well, they're all related because they're all yellows, and all my yellows are increasing by 3, that repeated addition. So let's go on to our next one. In what context would someone use this? So that means, when would this be applicable or relate to real life? Well, I should know right away it's going to be related to real life if I'm a painter, or if I'm going to paint my room and I need an orange paint, and all they have is red or yellow. Or I don't like the orange colors that they have, so I need to make my own orange that I like. So this information will be useful to anyone who has need to paint a surface and also has to mix his own paint. So maybe you don't like that orange colors they have, or you want to just make your own. Okay, so now what we need to do is we need to interpret what this table means. If I use 5 gallons of red paint, how many gallons of yellow paint would I use? Well, I'm going to look on my table. I see this 5 for red, and I just look over and I see which number is right next to it. Well, it's that 15. So I'm going to use 15 gallons of yellow paint if I use this 5 gallons of red. I want to keep that same color of orange. Okay, now let's look. How is the amount of yellow paint related to the amount of red paint? So let's look. How is this one related to this? Or how is this one related to that? We know if I'm going the opposite direction, my numbers get bigger, and I'm multiplying by 3. It looks like I'm doing the exact opposite, though, when I go from here to here. How do I get from 6 to 2? Well, I'm going to divide by 3. Let's check. Does that work for all of them? 12 divided by 3 equals 4. So yeah, that is what I'm doing. The amount of yellow paint is always 3 times as much as the amount of red paint, and the amount of red paint is always 1/3, or division of 3. So is that true for all my entries? Yeah, we've seen that it's true. If I go bigger, or if I go my small number to my big, I'm always multiplying by 3. If I'm going from my small number, or my bigger number, to my smaller number, I'm always dividing by 3. So it's true for all my entries. Okay, now imagine that we want to make orange paint to cover an entire wing of our school, and we have 100 gallons of red paint. How can we figure out how many gallons of yellow paint to use? Well, what that's saying is, I have something. I'm just going to cover up this part, just so we have an empty row to work on. So it's saying, how much red do I have? Well, I have 100, and I need to figure out how much yellow do I have. Well, my table doesn't go that far, and I probably don't want to go 5, 6, 7, 8, 9, all the way to 100. So what do? I'm going to use this relationship again. How did I get from this number to here, or this number to here? It's easy. I'm multiplying by 3 each time. So what do I need to do to that 100? Well, it's going to be 100 times 3. And what does that equal? Well, 100 times 3, I know, equals 300. So how much yellow paint do I need to use? I need to use 300 gallons of yellow paint. Okay, let's see. How can we write an equation? So remember, an equation is a left side and right side. We've already done this. So now let's read our directions to see what we can do to make an equation that's actually a little more useful. When we were given 1 gallon of red paint, we knew that we would need 3 gallons of yellow paint. What if we were given R gallons of red paint? How many gallons of yellow paint would we need? So the number of gallons of yellow paint would equal what? Let's look at this. I'm going to do the same thing. I'm just going to block this out so we have an extra row to work with. So it's telling us we're given R gallons. Remember, from our equations unit, we don't know what R is. It could be 2 gallons, could be 13, it could be 27/9. How many gallons of yellow paint would we need? So they're telling us we need to figure out what goes in here. Well, let's look. Actually, I'm going to take that off. We're just going to do it without. So how do I get from here to here? Well, I was always multiplying by 3. So how do you think I'm going to get from here to here? Well, I'm also going to multiply by 3. It's going to be R times 3. Just because I have a variable in here doesn't change the relationship. So what is my answer? I'm going to need 3R. So that's going to be my equation. My yellow paint equals that 3R. So now it's going to be really easy for me. If I know R is 200, I just put 200 in for my equation. And I'm ready to go. Yellow paint equals 200 times 3. And so I would need 600 gallons of yellow paint. If my R was something different, like 13, I just substitute that 13 in. Alright, so now we're on to another problem. Ian now plans to mix red paint and blue paint to create purple paint. The color of purple he has decided to make combines red paint and blue paint in a ratio of 4:1. So, what is that telling me? My red paint is 4 and my blue paint is 1. If Ian can only purchase paint in 1 gallon containers, construct a table for all the combinations of red and blue paint that will give Ian no more than 25 gallons. So what am I going to start with? I'm going to start with 1 blue, 1 red, and I just have this total paint just so I know how many total gallons. I'll give you a hint. The reason why is I'm going to be focusing on this 25 gallons. And so my 25 gallons is when I mix these two together. So I can't have more than 25 gallons of my total paint. So let's continue. Well, if I have 2 gallons of blue, I'll have 8 gallons of red because I'm doubling, which makes 10 gallons. And I'm just going to keep going my chart. Each time this increases by 1, this is increasing by 4, my total will increase by 5. Think in your head, why does it increase by 5? Well, I have 1 plus 4, so that's giving me that 5. So my table is going to keep on going and keep on going. So here I have my ratio table. That's all it's asking me for, is create a ratio table. Okay, now we have a different problem. It's almost the same, but slightly different. Complete the table below to show the relationship between blue paint and red paint. So let's look. Here's my blue, red, already filled out. What's my relationship? So let's say, how do I get from here to here? Well, how do I get from here to here? I should notice something. It's always my blue paint times what? Times 4. So what is it for this first expression? Well, it's 1 times 4 equals 4. Well, it'll be for this second one. It's going to be 2 times 8. I'm sorry, 2 times 4 equals that 8. What is this one going to be? It's 3 times what? Times this 4 again. I'm always multiplying by 4. This is going to be 4 times 4 equals what? 16. And 5 times 4 equals what? Equals this 20. So that's my relationship. So now it's asking, what equation can show how much blue paint I need? So it's asking, how can I see how much blue paint I need? Well, what that's saying is this. If I get rid of this last column just so we have a place to work, if I have blue, how do I know how to end up here? Well, what I'm seeing is I'm always taking my blue paint every single time, and I'm doing what to it? I'm multiplying by 4. Every single time I was doing that multiplication by 4. So it's not going to be anything different here. I'm taking my blue, the only thing different is a variable, and I'm multiplying it by 4. So what does my red paint equal? My red paint equals B times 4, or R equals 4B for that equation. Oops, I was getting a little ahead of myself. And my red equation is going to be what? My red equation is asking me, how do I get from here to here. How do I get from here to here? Well, I should notice it's the exact opposite. Instead of multiplying by 4, what am I doing? I'm dividing by 4. So if I know what my red paint is, what am I doing? Well, I'm dividing it by 4. So what that's going to say is this. My blue paint equals what? 1/4 of 4, or 1/4 of R, or I can rewrite it like this. R divided by 4. Why is that? Well, remember, if I multiply by a fraction, it's the same thing as if I divide by my denominator and multiply by my numerator. They're both equivalent. Alright, so my blue equals what? Blue equals that 1/4 times R, which we also know is just the same as R divided by 4. You can use whichever one works for you, the division or the multiplication. And then my red is that R equals 4B that we just went through. Okay, let's look at this one. What equation models the relationship between the blue paint and the total amount of paint? So what is it asking us to do? Well, let's look right here. I'm going to show you the answer, then we're going to discuss how we got it. Oops, but I showed you the answer to the next one too. That was my mistake. So it's asking us, how are we getting from here all the way to here? How are we getting from my blue paint to my total? Well, hopefully you see that I'm multiplying by 5. Now what if again I have this problem? I don't know how much blue paint I have. Well, it still doesn't matter. I'm still taking my blue paint, even if it's a variable, and I'm doing the same thing. I'm multiplying by 5. So what is that? Well, my total paint equals what? B times 5, or that 5B. So now it's asking us to do what? The value of the ratio of the total paint to blue paint is what? So remember, the value means what? A simplified fraction. So I'm finding my total paint to my blue paint. And what is that? Well, that's going to be 5 to 1. And what does that mean? Well, it means this. I'm going to then rewrite as a fraction and simplify. So my value is just this. It's just 5. Now I want you to think, how is the value, my value is 5, related to my equation? Well, hopefully you see my value is actually the coefficient. It's actually that number right in front of the variable. Okay, so let's work on some of these. During a particular U.S. Air Force training exercise, the ratio of the number of men to the number of women was 6 to 1. Use the ratio table provided below to create at least 2 equations that model the relationship between the number of men and number of women participating in the training exercise. Well, I should see right away my ratio is 6 to 1. Why is this 1 first, and up here I see it's the second number? Why is this 1 here, but right here's the second number? Well, remember, you have to make sure you're paying careful attention. This ratio is my ratio of men to women, but how they set up the problem was they put the women first. So I have to make sure when I'm doing women that it's going with this right number. So this 1 goes with the women, and the 6 will go with the men. So I'm just going to continue filling my chart out. By now you should see, I shouldn't have to explain how I'm filling this out for my equivalent ratios. Okay, now what is it asking us for? That's the key part. It's asking us for this. Use the ratio table below to create at least 2 equations that model the relationship. So it's saying, what's 2 ways that I can show how one side is related to the other? So what's one way I can show how this is related to this? Well, hopefully you should see that I'm multiplying by what? By 6. So my women equal what? Equals 6 men. My women equals 6 times m. Is that true? Well, if I put 5 in, I should get 30. 6 times 30 equals what? Equals 180. Whoa, that's not right. So this is why we make sure we check our equations. So what did I do wrong on that one? Is it my women equals 6 men? No, it's actually my men equal 6 times the number of women. Now let's check it again. My women is 5, so this should equal 30. 6 times 5, 5 coming from right here equals 30. That's correct. So this is one equation. What's another possible equation I can do? Well, I can do the reverse. I can say, how am I getting from here to here? Well, I can say that my women equal what? Equal my men. But how am I getting from here to here? Well, I'm dividing by 6 each time. You can notice it's the opposite operation. I'm dividing by 6. Now let's check just to make sure. My men, I'm going to say, I'm going to pull this 12. So 12 divided by 6 should give me 2. And yes, it does. It's the same thing if I wanted to write it as a as a fraction. I could say women equals 1/6 times m. These two equations are equivalent. So that's just for 2. We have 2. I want you to look though, because there are actually some more that we could have written. So take a look at these. These were the 2 that we wrote. These ones are also equivalent. If you're curious why, you can look at them. You can plug some numbers in and you'll see you'll get the exact same answer. If you're not that curious, we can go on to our next problem. Okay, let's look at this. 200 women participate in the training exercise. Use one of your equations, so here are my equations, to calculate the number of men who participated. Well, let's look. It's asking me to calculate the number of men. So that's saying I need to find the number of men. So I don't know how many men there are, so I'm going to use this equation right here. It's telling me I know how many women there are, so I'm just going to put this 200 in for the women. So it's going to be men equals 6 times 200. Now what is that? 6 times 200? Well, that is 1,200. So how many men participated? Well, 1,200 men participated. Okay, let's go on to our next problem. Jose is on a road trip. During the first 5 minutes of Jose's trip, he sees 18 cars and 6 trucks. Assuming this ratio of cars to trucks remains constant over the duration of the trip, complete the ratio table using this comparison. Let T represent the number of trucks and C representing the number of cars he sees. So let's complete it first. Well, my ratio of cars to trucks I'm seeing is right here. So I'm going to do that first. Let's look for this 18 number. And I see it right here. How many trucks should I have? Well, that should be 6. And then I'm just going to now fill out my ratio table. And now I'm ready to begin. What is the value of the ratio, the number of cars to the number of trucks? So it's saying, what is the value of the ratio of cars to trucks? Well, it's 3 to 1. And value, that keyword, means what? It means I'm going to write it as a fraction. That's 3 over 1. That's going to simplify to just 3. So that is my value. What equation would model the relationship between cars and trucks? Well, I have several of them. So how do I get from cars to trucks, or trucks to cars? Either one's fine. So I'm going to do the simple one first. Well, how am I getting from my left side to the right? Well, I'm always multiplying by 3. So my relationship is going to be what? It's going to be my trucks times 3 equals cars. What's another relationship I can draw? Well, I can draw how is my right side related to the left. It's the same, but it's opposite. So it's going to be what? Cars divided by 3 equals trucks. Those are my equations that I can write. Okay, so let's work on our next part. So here are my equations. At the end of the trip, Jose counted 1,254 trucks. How many cars did he see? Well, my cars is the unknown. It's telling me I know how many trucks. So my cars is the unknown, so I'm going to use this equation. So I'm going to plug this number in for t. So I'm going to have 3 times 1,254 equals amount of cars. So I'm just going to do my work off to the side. I'm going to rewrite my problem, and then I multiply. 2 carry the 1, 6 carry the 1, 7, 3. So I have 3,762 cars. Alright, I believe this is not our last problem, but close to it because you still have your exit ticket. Martin is training to run a half marathon. His training program recommends that he runs 5 minutes for every 1 mile he walks. Hey, that sounds like a ratio right there. Minutes run to minute walked. Let R represent the number of minutes running, W represent the number of minutes walking. So I'm going to look right here, saying 5 minutes for every 1 minute walk. So I can just fill in my ratio table. And now let's begin. What is the value of the ratio of the number of minutes walking to the number of minutes running? So I'm looking for what? Walking to running. So let's look. Walking is 1 to 5, and I rewrite that as a ratio in a fraction form, and then I simplify. So there's my value, is 1/5. Okay, let's go on to the next problem. What equation could you use to calculate the number of minutes spent walking if you know the minutes spent running? Well, it's saying calculate walking. So I don't know what the walking is, so I'm going to ask myself, how do I figure out the walking? So this is what I don't know, is this minute walking. But it is saying I know my minutes spent running. However, it's not saying a number, so we have to assume it means a variable. We can also assume that because why else would they give us the variables to use up here? So how do I get from here to here? Well, I'm going to look at my ratio and ask a simpler question. How am I getting from minutes running to minutes walking? Minutes running to minutes walking. You should see that I'm dividing by 5 each time. So it's the same thing with my variables. How do I get from here to here? I'm going to divide by 5. So it's going to be minutes walking equals minutes running divided by 5. So this is my equation. If I know how many minutes I spent running, I just plug that in, and it'll give me the answer out. So if it's 100 minutes running, I could put 100 in, divide by 5, and it will give me 200 minutes I would walk for Martin's training regime. Okay, so here's our lesson summary. The value of a ratio can be determined using a ratio table. Done that. Piece of cake. This value can be used to write an equation that also represents a ratio. So that's what we've been looking at. How do we go from here to here and then write an equation with that? So this example would be, I'm going to say this would be A and B. B would equal 4 times A. That's all we're saying for that equation. We use that value. The multiplication table can be a valuable resource to use in seeing ratios. Different rows can be used to find equivalent ratios. We did not do that because of time, but if you're curious, just pull out a multiplication table and see if you can see what it's talking about. Alright, this is your exit ticket. I'm going to have you complete on Socrative and turn in a piece of paper that has your exit ticket on it as well. Alright, when you're done, what you're going to do is you're going to go to Khan Academy. You're going to do 2 lessons. Then you may do math games or ratio rumble after you've done 2 Khan Academies. Alright, good luck.